All right, so let's do the application exercise. So the first thing I'm going to do is I'm going to add my name as the author here. And just following the steps, you want to make sure you open RStudio Pro, create a new project, click File, New File, R Markdown, delete everything except for this top part, add in your name as an author, give your work a nice title, and of course when you're finished, knit and submit to Canvas. You guys have been doing this quite a bit, so I think you're probably pros at this by now, but just as a reminder of what you need to do. Okay, so I'm going to copy this code that I'm going to need here. I'm going to stick this up at the top. I'm going to just label this chunk as load package, and this is also where I'm going to get my data. Okay, so the first thing I want to do is fit a model predicting salary from at-bat and home run. And so here I'm going to use LM, and I'm going to do salary at-bat plus home run. And the data is going to be hitters underscore CC. All right, so there's my model. I'm going to save this as LM underscore hit. And the next question asks me to perform an F-test for the null hypothesis that the coefficient associated with home run is 0. So this is my full model here, LM hit. I need to fit a smaller model, and so I'm going to call this just LM small. And that's going to have just at bat in it because I'm interested in comparing a model with only at bat to one with at bat and home run. And so just to remind us, my null hypothesis here is that the coefficient for home run, which is going to be our beta 2, is equal to 0. My alternative hypothesis is that beta 2 is not equal to 0. Okay, and I've got LM hit and LM small. And so now how do I do that F-test? Well, I just use the ANOVA function, and I can run LM hit, comma, LM small. And what do I get for that? Well, there we go. We end up with this p-value. Here's F statistic of 7 and a p-value of 0.008. And so what does that mean? That means that, and actually let's take a little closer look at this because we've got model 1 is our full model, model 2 is our small model. And if you notice, my degrees of freedom actually comes out as negative and my sum of squares comes out as negative. And so let's see what happens if I switched the order of that. If I did LM small first and LM hit second. So when I do that, my F statistic and my p-value remain the same, but my degrees of freedom now are positive and my sum of squares are positive. And so typically this is the order, actually. You want to put small first, then big. Okay, so my F statistic is 7. My p-value is 0.008. And so what that means, let's interpret that real quick. So that means that the probability of seeing an F statistic as extreme or more extreme than 7.017 given beta 2 equals 0. So given the null hypothesis is true, is 0.008567. So the probability of seeing an F statistic as extreme or more extreme than 7017, given the null hypothesis is true, is 0.008567. We reject the null hypothesis at the alpha equals 0.05 level. Okay, so this is the full explanation that I would want you to give when you're describing an F statistic. I want you to say what the F statistic is, so make sure you state what it is, you state what the p-value associated is, you state what the null hypothesis is, you explain that p-value in the context, and then you tell me, therefore, either we reject the null or we fail to reject the null. And so, it's when you're writing this sentence, it's best practice to say, therefore we reject the null hypothesis, say what that null hypothesis is, that beta 2 is equal to 0, and you say at what level. So this is really important because you need to state that we're rejecting this at the alpha equals 0.05 level. because it's possible to have a different level that you're choosing to reject or not reject based on. And so having your result grounded in that alpha value is crucial. For example, if I was doing a null hypothesis, if I was doing a hypothesis test and my alpha level, let's say I set my alpha equals 0.001. What if that was my alpha level? Well, in that case, we would fail to reject the null hypothesis that beta 2 equals 0 at the alpha equals 0.001 level. The way you determine if you reject the null hypothesis is if that alpha level is bigger or smaller than the p-value that you saw. So if we set the alpha level at 0.001, well, 0.008 is bigger than 0.001, so we would fail to reject that null hypothesis. But if we set the alpha level at 0.005, and this is the most common one that you'll see, then we would reject the null hypothesis. So this is really, really important to the components there. So when you're talking about a statistic, you want to make sure you mention what the statistic is. You want to mention what the null hypothesis is, what the p-value is, how to interpret that p-value, whether you reject the null hypothesis, what that null hypothesis is again, and the alpha level at which you're doing that. Okay, so now we need to compare this to a t-test obtained from the summary statement. And so let's do the summary of this LM hit object. And so when we run that summary for home run, we end up with a t-value of 2.649 and a p-value of 0.00857. That looks really similar. So it turns out that that p-value is exactly the same as the p-value for the F statistic. And you can prove theoretically why that makes sense. But basically why this is important is because if you're just interested in testing if a single coefficient is 0, you can actually skip the extra step of having to fit the two separate models, and you can just look at the t statistic and the p-value associated. Now, if you want to look at a subset, and so a grouping of variables, then the F-test is really quite nice for that. Okay, I'm going to give this a chunk label. Let's make sure I labeled all my chunks. Okay, we've labeled our chunks. Now I'm going to knit this document. Let's take a look at that. Got all my output here. It looks good. And so now we can go ahead and upload it.